Hear ye, the Honorable Judge Cellular now presiding. All rise.
The judge looked over at the jury. He could have pursed his lips if he wanted to do so, for he greatly wondered at this particular jury that was filled with prokaryotic cells. Prokaryotic cells? It hardly seemed fitting that they would be sitting in a judgment of a eukaryotic matter. Prokaryotes? What did they know about eukaryotes?
Ahem! Let us see now. This is a case of the state versus egg cell number 6624224. This presents an unusual situation involving an alleged capital offense. The defendant is charged with being an undesirable mutant in the body politic. The penalty is death. This is the most serious of matters. It requires our undivided attention. So let us begin. Statements. But please keep your comments brief and to the point. The prosecution first, arguing the position of the state. I believe it is Miss Liv, is it not?
Members of the jury, I come to you today as a member of your cellular community. I come from a long line of cells that stretches back to a time when the world was once filled with only prokaryotic cells like yourselves. For over 1 billion years you ruled the world. We eukaryotic cells are but recent upstarts. For the most part, we live in colonies making up the bodies of animals, plants, and fungi. I, in fact, am a liver cell, one of several trillion cells living in the human I'll call Martha. It is essential that we all live in harmony with one purpose in life, that is, survival. If Martha doesn't survive, we all die. I and the rest of the liver cells, the kidney cells, the muscle cells, the nerves, and all of the others that make up this grand human being. Yet this is not all. Our individual survival is only part of the story. We would not be here except for the fact that we are all descendants of untold numbers of other organisms, many of them complex colonies of cells, for the last 700 million years. And we have relied on sex. Yes, I know that this concept is one that you asexual cells hardly understand, but as you have certainly read, in humans like Martha, the cells in her ovary produce some unusual cells called eggs. And in Martha's husband, there are some cells called sperm. If these two cells get together, they will produce a fertilized egg that may grow up to be another colony of cells we call a baby. Now, the point of all of this is that in order to produce a perfect baby, the sperm and the egg must be perfect. This brings me to the central issue of this crime. The defendant on the stand today is one of Martha's cells. We all love Martha. Some of us have lived with her for years, but as we will all show, she has been alive for 43 years and this has led to trouble. Many of her eggs are flawed, and this is exactly the case with our defendant, egg cell number 6624223. She is not perfect. It is our contention that she should be destroyed by apoptosis. She is not just contaminated by a single point mutation, she is disfigured by having an extra chromosome 21. This invariably leads to Down syndrome. She should be destroyed so that a pure lineage can go on. We believe that you will see the wisdom of this solution by the end of the trial and trust in your good judgment.
Thank you, Miss Liv. Now, Counselor Osite, would you like to give your opening remarks?
Thank you, Your Honor. Cells of the jury, you have heard the remarks of my colleague. She argues that my client is flawed. She bases that on unsound logic. We will stipulate that my client is unusual, but that does not mean that she is flawed or damaged. In every part of Martha's body, there are unusual cells. Some cells in the lining of her digestive tract are triploid or even have higher numbers of polyploidy. Her liver cells, and perhaps Miss Liv herself, are filled with unusual numbers of chromosomes. Some have 3, 4, 5, 6, 7, or even more sets of chromosomes. Miss Liv here appears in the pink of health. What's there to be troubled about? These cells are all healthy lives and contributing to Martha's welfare. There is hardly a reason to get upset with my client, who has a single extra chromosome 21. And, as is well known, even if a Down baby is the result, these children live happily, wholesome lives. We will clearly demonstrate to the jury that death is hardly a reasonable remedy, and that, in fact, there is no crime that has been committed at all.
Thank you, Counselor. Now, Miss Liv, you may call your first witness.
Your Honor, I call Mr. Nuclear Membrane of the Epidermis to the stand.
Bailiff, administer the oath.
Do you swear to tell the truth, so help you DNA?
I do.
I am calling Mr. Nuclear Membrane here as an expert witness on the process of cell division.
I object, Your Honor. Mr. Nuclear Membrane cannot serve in this capacity, as he is simply an expert in the topic of cell division that occurs in skin cells. This is hardly the same as which occurs in sex cells, and that is the subject of this case. Although cell division in the skin cells is just like cell division in almost everywhere else in the body, Cell division is entirely different in the ovaries and the testes, where the sex cells are manufactured. The skin cells divide by mitosis. The sperm and eggs are produced by meiosis. Altogether, a different process.
Miss Boyack objects. Counselor Liv, what do you say?
I am not calling Mr. Nuclear Membrane as an expert witness in meiosis, but as one on mitosis. I wish to lay the groundwork for making the distinction between the two.
Then I withdraw my objection, Judge, and so you will stipulate that the gentleman is an expert in mitosis and nothing else. Go ahead, this should be interesting.
Now, Mr. Membrane, please describe the events of simple cell division that occurs in the skin. I believe you have some diagrams to show the jury that will help. Bailiff, would you please place the exhibits on the easel?
Yes, Miss Liv, I do. First, I want to stress that the normal skin cell divides repeatedly in its life. Skin cells are always being wiped away when Martha's hands rub against anything. We do indeed have a busy time keeping up with the wear and tear of everyday living. When Martha's cells get ready to divide, the genetic information has to be copied. You know what I mean. If you're going to make another cell just like yourself, you've got to make sure that the next generation knows what to do. You've got to send the right information, right? So the cell has to make a copy of the instructions in the DNA. You know, the genetic material. So here's the deal. The scientists that study this stage in our life cycle call it interphase. That's what's shown in Exhibit A. This is the time when we were really living it up, growing like crazy, making proteins like there's no tomorrow, and making little organelles. But then things change in a big way. The cell has gotten too big, you might say. It's got to divide, and that's when DNA makes a copy of itself. Now take a look at the diagrams that show the next steps. All of them have special names. There's early and late prophase, metaphase, anaphase, and then my favorite, telophase.
Please tell us what's the overall gist of what's happening.
Well, it's no mystery. Look here at Exhibit B.
The DNA has made an extra copy of itself, gets all wrapped up into wads you call chromosomes.
But each chromosome has two parts. You know, the original part and the copy. They're called chromatids. The parts, that is. The two parts of each chromosome are linked together at a point in their middles.
So what happens next?
Well, in Exhibit C, you can see that the chromosomes lining up in the center of the cell, and then in Exhibit D, the pairs of chromatids split apart and go off to opposite sides of the cells.
They're pulled there by fibers. All of the chromosomes are doing the same thing, all at once. Half of their chromatids go to one side and half go to another.
That way, each side of the cell gets a complete set.
Just a moment, Mr. Membrane. Where do these fibers come from? It looks like they come from the centrioles.
That's right, but I'm not quite sure, as I've never really been around to see that part of the story. I've been told that—
Objection! That's hearsay, Your Honor.
Objection sustained.
Let's try this again, Mr. Membrane. What have you seen yourself?
the chromatids are separated and dragged to the opposite sides of the cell, and that's when I reappear. See, that's me, right here in Exhibit E.
In two places, actually. I make a nuclear membrane that surrounds the chromosomes on both sides of the cell. You know, that's my job, to surround the DNA for the two new cells.
I'm making two nuclei for the next generation of cells.
Let me be sure I have this right. The chromosome material, the DNA, makes a copy of itself, then bundles itself up so it can move to the center of the cell more easily. The two copies of the DNA are wound into separate bundles called chromatids that are bound together. They line up at the center of the cell and then become separated by some fibers that pull them apart. So one set of chromatids, I presume you call them chromosomes at this point, goes to one side of the cell and the other set goes to the other side of the cell?
That's right. You see, when the cell starts to divide, that is, when the cytoplasm in the center of the cell begins to pinch off the two parts, both sides get a complete set of chromosomes. In humans, there are 46 chromosomes. So every time a skin cell makes a copy of itself, both cells get a complete set of 46 chromosomes. Then each cell reverts to interphase. It's wonderful, don't you think?
Yes, I do. Thank you for your testimony. Now, Counselor Oasite, the witness is now yours for cross-examination.
Thank you, Judge. Now, just to be sure I have this right, Mr. Nuclear Membrane, do I understand that you disappear during the process and reappear in the end?
That's right. I have to sort of break apart in the early prophase so that the chromosomes can move to the center of the cell. They couldn't do this if I were in the way, could they?
No, I don't suppose they could, Mr. Nuclear Membrane. Then the next time you see anything happen is when you reassemble around the two new sets of chromosomes on the opposite sides of the cell. That is the reason telophase is your favorite time, isn't it? So everything else you've told us in between these two times is merely scuttlebutt, isn't it?
I would hardly call it that. It is well known that
Let's move on to another question, shall we? Tell me, when the DNA makes a copy of itself, is the copy always perfect?
well, most of the time, it has to be. Otherwise, the cell might be sick, become cancerous or something.
But that isn't what always happens, isn't it?
No, I guess not.
Isn't it true that many cells have so-called imperfect copies of DNA during mitosis, and things aren't disastrous? In fact, things are often pretty good, aren't they? Sometimes these somatic mutations turn out well. I'm thinking of cases where a hair cell on the head of a person like Martha mutates, and the person has a nice stripe of white running through their hair. That's pretty striking, isn't it? Wouldn't you say you wouldn't say that that is bad, would you? Or abnormal? Or a reason to destroy Martha or her mutant cell? No, I thought it would not. It depends on the situation, doesn't it?
Yeah, I guess so.
No further questions, Your Honor.
You may now step down, Mr. Nuclear Membrane, and I believe we have had enough testimony for today. Now we will resume tomorrow at the same time. Court is in recess.